Ever had a cold radiator and thought, just turn up the boiler pressure? Here's why that's a bad idea. The logic goes more pressure equals more heat. So the pressure is increased from 2 to 5 pounds. Sounds reasonable. And the weird part is you get rewarded. That radiator that was cool gets a little bit warmer. But in the steam system, that simple adjustment is one of the fastest ways to increase fuel bills, start a symphony of banging pipes, create new problems, and hide the real issue. Let's talk about why turning the pressure up actually costs you more money. Welcome to Boiler Room Detective. I'm your host, Ray Wohlfarth. My comprehensive series, 14 boiler books, covers everything from installation and troubleshooting to advanced system design. These are available now at Pronto Heating Supplies, TF Campbell, heatinghelp.com, and Amazon. First, here's the most important thing to understand about steam. Steam doesn't heat because of pressure. Steam heats because it changes state. When steam condenses back to water inside a radiator, it releases a huge amount of heat called latent heat. That happens whether the steam is at a few ounces or several pounds. Most older steam systems were designed to run at very low pressure, many under 2 psi. Some vapor systems run at just a few ounces. So when you turn the pressure up, you're just changing how the steam behaves and not in a good way. Here's the next problem. As the steam pressure rises, steam temperature also goes up. At 2 psi, steam is about 219 degrees. At 5 psi, it's closer to 227 degrees. That extra temperature causes the radiators that heated faster than the cold one to heat even faster, causing an even greater temperature difference. Thermostat shuts off the boiler sooner, and that leads to something boilers hate: short cycling. Every time the boiler starts, it has to pre-purge, establish draft, heat up cold metal. All that burns fuel before useful heat even reaches the building. Short cycles means more starts. With more starts, you get more wasted fuel and more wear on the boiler. So higher pressure doesn't make the system more efficient, it makes it more erratic. Let's talk about the real enemy in the steam system. It's air trapped in the pipes and radiators. Steam can't move until the air is gone. That's the job of air vents. When venting is slow or undersized, steam stalls. So what happens when someone turns the pressure up? The steam starts compressing the air instead of venting it. That creates back pressure, slows steam down more, and the boiler runs longer trying to overcome resistance that shouldn't be there in the first place. Again, longer run times equals higher fuel bills. Higher pressure steam moves slower than lower pressure steam through the piping. That slows the steam going to the cooled radiator. At 2 psi, steam travels at 31 feet per second. Increasing the pressure to 5 psi slows the steam to 26 feet per second, 17% slower. Steam volume also decreases as the pressure rises, which means you need to generate more steam to fill the pipes. Steam at 2 psi has a volume of 24 cubic feet. Steam at 5 psi has a volume of 19 cubic. You need to generate 21% more steam at 5 psi than you would at 2 to fill the system. Higher steam pressure increases the flash steam. Steam at 5 psi is 227 degrees Fahrenheit, meaning the condensate temperature is about 217 degrees, well above boiling. If you have a mechanical return system, that flash steam is wasted out the vent. A new makeup water must be introduced to replace the water you heated or treated. Inside a condensate pipe, the flash steam fills the pipe and inhibits airflow because steam and air can't occupy the same space. So the rads filled with air stay filled with air. Instead of condensate pipes filled with air and condensate, they are filled with steam. Let the banging begin. The A dimension is the difference in height between the lowest steam pipe and the boiler water level. It's used to help push the condensate back into the boiler. When you increase the steam boiler pressure, the A dimension has to be higher to overcome the boiler pressure. You can't raise the pipes, so the condensate backs up into the horizontal steam pipe, and it sounds like a Blue Man concert. Turning the pressure up doesn't fix the problem, it hides it. Cranking up pressure is like turning the radio louder because the engine is knocked. When steam systems run at low pressure, steam fills the system evenly. Radiators heat together. Thermostats are satisfied gradually. The banging goes away. The boiler runs longer, but fewer times. That's efficient operation. Steady combustion, less cycling, lower fuel consumption, and a much calmer boiler room. So if a steam system isn't heating properly, don't touch the pressure control first. Check the air venting, check and verify the pressure control is accurate, inspect the near boiler piping. Most steam systems want the lowest pressure that gets the job done, and that pressure is lower than people think. Turning the pressure up feels like a quick fix, but it costs money. It shortens equipment life, and it creates new problems. I'm Ray Wohlfarth, the Boiler Room Detective, and I'll see you on the next case.